This video covers Chapter 3, Cloud Computing Model. Chapter 3 focuses on cloud service models. These are primarily grouped into three main categories: software as a service, or SaaS at the user level, platform as a service, or PaaS at the development level, and infrastructure as a service, or IaaS at the infrastructure level. Let us understand software as a service, or SaaS, in a very simple way. First, the software is hosted in the cloud. This means it runs on remote servers in a data center, not on your own computer. The infrastructure is managed remotely, so the company that provides the service takes care of the servers, storage, and security. Second, it is accessed through the internet. You only need a web browser. For example, when you use Google Docs, you open it from Chrome or Edge anywhere, even at home or in a cafe. Third, it is used without installation. There is no local setup required on device. You do not download heavy files or worry about storage space. So the main idea is focus on usage. Users focus on using the software, not managing it. There are no updates and no maintenance for you to handle. Everything is done by the provider behind the scenes. The key idea of SaaS is that the provider runs the software, manages updates, and handles all maintenance. The user's role is simple. They just log in and use the service via a device connected to the internet, without worrying about the underlying cloud infrastructure. SaaS is commonly accessed through web browsers like Chrome, Firefox, or through dedicated mobile apps. The primary benefit here is that no local installation is required on user devices. You simply log in and go. In a SaaS model, users control their accounts, their data, and basic application settings. However, users do not control the underlying servers, operating systems, or software updates, as those are managed by the provider. SaaS providers manage everything else, including the infrastructure, operating systems, application installation and configuration, and all security updates. This structure significantly reduces the technical burden on users, as the provider handles all hardware and patching. Now let us look at examples of SaaS usage in daily life. SaaS is commonly used for email services like Gmail, Outlook, and Yahoo Mail. You open your browser, log in, and send messages. You do not install a mail server. Everything runs in the cloud. Next is online document editing, such as Google Docs and Office 365. You can type an assignment, and your friend can edit it at the same time. The file is saved online, not on your laptop. Another example is customer management systems, also called CRM. CRM means customer relationship management. Tools like Salesforce and HubSpot help companies store customer data and track sales. We also use SaaS in learning platforms like Canvas, Coursera, and Moodle. You watch lectures, submit work, and check marks online. All these show zero setup. These services are used daily without technical setup. Just log in and start using. SaaS offers several advantages, such as easy access from anywhere with an internet connection, low setup costs, and automatic updates. Minimal technical skill is required, making it user-friendly, hassle-free, and suitable for beginners. Now let us discuss the limitations of SaaS. First is limited customization. Customization means changing the system to fit your exact needs. In SaaS, you usually must follow the standard design. For example, a company using an online HR system may not be able to change the workflow fully. Second is dependence on internet access. If your internet is slow or disconnected, you cannot use the system. Imagine trying to submit an assignment on Moodle, but your Wi-Fi is down. Third is less control over system behavior. The provider controls updates and settings. This is called standardization, where users must accept provider-defined features. You use what is given. So SaaS is convenient, but it comes with fixed features and online-only access. Software as a service, or SaaS, is most suitable when users need quick solutions and rapid deployment without installation delays. It's ideal when IT resources are limited and you want to avoid maintenance responsibility. SaaS is commonly adopted by small organizations, startups, and universities. Moving on to Section 3.2, Infrastructure as a Service, or IaaS, gives the user the highest level of control compared to PaaS and SaaS. Let us understand what is infrastructure as a service. Infrastructure as a service provides basic IT resources through cloud delivery. This means the resources are delivered through the cloud, not kept in your office. First, it provides virtual machines. A virtual machine is like a computer inside a computer. It gives on-demand computing power, so you can create a server anytime without buying one. Second, it provides storage. This is scalable data storage solutions. Scalable means you can increase or decrease space easily. For example, if your app suddenly has many users, you can add more storage quickly. Third, it provides networking resources, such as virtual networks and load balancers. A load balancer shares traffic, so one server does not get overloaded. All these services can replace physical hardware. You do not need to buy real servers. You rent and manage them online. Here is the key idea of IaaS. In IaaS, the provider supplies infrastructure such as hardware, servers, and network backbone. The network backbone means the main internet connection system, but the user manages OS and software. OS means operating system like Windows or Linux. For example, AWS gives you a virtual server. They handle the physical hardware, but you install and control the OS and applications. This gives users high flexibility and control. IaaS provides virtual servers, virtual storage, and virtual networks. Virtual means not physical, but created by software. A virtual server works like a real computer, but it runs in a data center. Virtual storage stores your files online instead of on a hard disk. Virtual networks connect systems through the internet. These components replace physical hardware. For example, instead of buying a server for your company, you rent a virtual one from AWS. Now let us see what users control in IaaS. In IaaS, user control is high, but with high control comes responsibility. Users are responsible for system management. First, you control the operating system. This means you choose and manage Windows or Linux. You have full root or admin access, which means full permission to change system settings. Second, you control installed software. This includes middleware and runtimes. Middleware is software that connects applications to the operating system, like a web server. Third, you manage your applications, including your own code and data. Finally, you handle system configuration, such as firewalls, updates, and settings. For example, if you forget to update security patches, it is your responsibility. So in IaaS, control is high, but so is your duty to manage everything properly. So far we have discussed what users control in IaaS. Now let us examine what remains under the provider's control. In IaaS, providers manage the physical hardware. This means the real servers, storage devices, and cables inside their facilities. They also take care of the data centers. A data center is a secure building filled with many servers, power supply systems, and cooling systems to keep everything running safely. Next is the network infrastructure. This includes routers and switches that allow data to travel between servers and to users through the internet. Providers are also responsible for hardware maintenance. If a server fails, they repair or replace it. This is known as offloaded responsibility. Users do not handle physical equipment. There is zero hardware management on your side. You focus on software, while the provider manages the physical foundation. Now let us talk about the flexibility of IaaS. IaaS allows users to choose system specifications. This means you can select CPU, RAM, and disk space. CPU is the processor that handles calculations. RAM is memory for running programs. Disk space stores your data. For example, a small website may need low RAM, but a gaming server needs more. You can also scale resources up or down. Scaling means adjusting capacity based on demand. During a big online sale, a company can increase server power. After the sale, they reduce it to save cost. IaaS also lets you deploy custom environments. This means creating special system settings for your project, such as a testing server. Because of this, IaaS supports diverse system needs. It is a highly adaptable infrastructure for different requirements. Now let us explore the use cases of IaaS in a practical way. IaaS is commonly used for hosting websites. For example, an e-commerce company can host its website on Amazon EC2 or Microsoft Azure virtual machines. If many users visit during a promotion, the server can increase capacity to handle the traffic. When traffic drops, it can scale down to reduce cost. It is also used for running custom applications. A company may develop its own payroll or inventory system and deploy it on a virtual machine. IaaS provides a flexible environment for this specialized software. Another important use is system testing environments. Developers can quickly create a separate server for QA. QA means quality assurance, where software is tested to find errors before going live. IaaS is also useful for backup servers. Companies store copies of data in the cloud for recovery if their main system fails. The target user usually has technical knowledge, because IaaS provides the basic infrastructure that professionals configure and manage themselves. Let us look at the advantages of IaaS. IaaS provides high control, so you manage your own system. You can make custom configurations, such as choosing software and settings. With pay-as-you-use pricing, you only pay for what you consume. This reduces cost. It also offers scalability, which means you can increase or decrease resources anytime. This creates an ownership shift. It replaces traditional server ownership, and there is no physical maintenance needed. Now let's look at the limitations of IaaS. First, it requires technical skills. This means you need advanced knowledge to manage servers, networks, and storage. It is like renting an empty shop lot. The owner gives you the space, but you must design, install, and manage everything yourself. Second, the user is responsible for security configuration. You must handle OS patching, firewalls, and access control. OS patching means updating the operating system to fix bugs and security holes. If you forget to update, hackers may enter. Improper setup may cause security risks. Third, there is more management effort. You must do manual updates and system maintenance. Unlike SaaS, here the provider does not manage everything for you. So IaaS gives flexibility, but it also requires expertise and careful management. Now let us see when IaaS is most suitable, with real-life examples and reasons. First, when full system control is needed. For example, a bank runs its online banking system on IaaS. The bank wants full authority over the OS and stack, including security settings and network rules. The reason is strict security and compliance requirements. They cannot depend on fixed settings from a provider. Second, when custom software must be installed. A manufacturing company may use a legacy production system that was built 15 years ago. It only works on a specific Windows Server version. SaaS cannot support this. IaaS allows them to install and run that exact system. Third, when organizations have IT expertise. A large enterprise with a strong IT team can manage, secure, and maintain infrastructure themselves. The reason is they want maximum flexibility and can handle the technical responsibility. We now move to Section 3.3, Platform as a Service, or PaaS. PaaS offers a balanced level of control between software as a service and IaaS. Now let us understand what is Platform as a Service. Platform as a Service provides a ready-to-use development platform. This means the environment is already prepared for you to build applications. You do not need to set up servers or install operating systems. It also gives tools for building applications, such as code editors, databases, and testing tools. For example, if you want to build a food delivery app, you can start writing code immediately. PaaS also offers managed runtime environments. Runtime means the place where your code runs. The provider manages updates and security, so developers can focus on code, not infrastructure. It reduces development complexity and saves time. The key idea of PaaS is simplicity. The provider manages the underlying infrastructure and platform, while the user focuses on developing and deploying applications directly. PaaS provides essential components such as operating systems, development frameworks, databases, and runtime environments. These components are pre-configured, meaning no manual installation is needed. Now let us see what users control in PaaS. In PaaS, users control the application code, application logic, and data used by applications. Application code means the program you write. Application logic means how the system makes decisions. For example, how a food delivery app calculates delivery fees. You also manage the customer data stored in the app, but users do not manage servers, operating systems, or OS updates. The provider handles those parts. For example, if you build an online booking system, you focus only on writing code and setting rules. You do not worry about server setup or system updates. You are responsible for the app layer only. Let us look at what providers control in PaaS. Providers such as Amazon Web Services, Google Cloud, and Microsoft Azure manage the infrastructure, including servers, storage, and networks. They also manage the operating systems, so users do not install or update them. They handle platform updates, which means security patches, bug fixes, and improvements are done automatically. They also control scalability mechanisms. Scalability means the system can increase or reduce resources based on demand. For example, if you build a registration system on Google Cloud and many users log in at once, Google Cloud adjusts the resources to keep it running smoothly. This creates a stable environment that supports consistent and reliable development. PaaS plays a vital role in application development by helping developers build applications faster. It allows them to avoid environment setup issues and deploy applications easily, which boosts productivity and enables faster time to market. Let us look at the use cases of PaaS. PaaS is commonly used for web application development. For example, a team building an online shopping website can write code and deploy it quickly without setting up servers. The platform already provides the environment. It is also used for API services. An API, or application programming interface, allows different systems to communicate. For example, a food delivery app connects to a payment gateway using APIs. PaaS makes it easier to build and manage these connections. PaaS is popular for collaborative development projects. This means many developers work together on the same project. For example, a university team building a student portal can share the same platform, test features, and update the system together. That is why it is popular in software development teams. It supports dev focus and agility, meaning faster development and easier changes when needed. Let us understand the advantages of PaaS in a practical way. PaaS offers faster development because developers can start coding without setting up servers, operating systems, or networks. For example, when building an app using Google App Engine or Azure App Service, you simply upload your code and run it. It also provides reduced system management. The cloud provider handles server updates, security patches, and infrastructure. Developers do not worry about hardware or maintenance. Another key benefit is built-in scalability. Scalability means the system can automatically adjust resources when user traffic increases. If your app suddenly becomes popular, the platform handles the extra load. PaaS also ensures consistent environments. The development and production environments are similar, which reduces technical issues. The core benefit is that developers can focus on functionality, meaning the features and logic of the application. This leads to maximized productivity. Now let us discuss the limitations of PaaS. First, there is less control over system settings. Developers cannot fully change the operating system or server configuration because the provider manages the platform. For example, if you deploy your app on Azure App Service and need to install a special system driver or modify deep OS settings, you usually cannot. You must use the configuration provided by the platform. Second is platform dependency. This means your application depends on the specific platform. For example, if you build your app using Google App Engine and rely on its built-in database and authentication tools, moving to AWS later may require rewriting code and changing configurations. Third is limited customization options. For example, the platform may only support certain programming languages or specific database systems. If your preferred technology is not supported, you cannot freely install it. This is called strict adherence, where you must follow the platform rules defined by the provider. There is also a vendor lock-in risk, meaning switching providers later can be difficult and costly. Now let us understand when PaaS is most suitable. PaaS is suitable when application development is the priority. This means the main goal is to build features and improve the app, not manage servers. For example, a startup creating a food delivery app wants to focus on user interface and payment functions, not server setup. It is also suitable when time to market is important. Time to market means how fast you can release a product. If a company wants to launch a new online service before competitors, PaaS helps them develop and deploy quickly. PaaS is also ideal when infrastructure management should be minimized. This means reducing the time spent on server updates, security patches, and system configuration. The provider handles these tasks. This fits modern workflows, especially for agile teams. Agile teams work in short cycles and release updates frequently. PaaS supports this fast and flexible development style. Now we will compare the three major cloud service models: software as a service, platform as a service, and infrastructure as a service. The purpose of comparing service models is to understand different levels of control, responsibility, and flexibility. In SaaS, control is low. You just use the software, like Gmail. In PaaS, control is medium. You build apps, but the provider manages the system. In IaaS, control is high. You manage servers and configuration. Understanding these differences helps in choosing correctly for real needs. The control levels range from minimal in SaaS to maximum in IaaS. A key principle is that higher control requires higher responsibility from the user. In responsibility distribution, as user control increases, provider responsibility decreases. This trade-off defines each service model, with users managing more components in IaaS and fewer in SaaS. This slide shows the skill requirement comparison across service models. In SaaS, you need minimal technical skill. An end user simply logs in and uses the system, like sending email in Gmail. In PaaS, you need development skills. A developer writes code and deploys applications on the platform. In IaaS, you need system administration skills. A sysadmin manages servers, networks, and infrastructure settings. Users must match skills to service model. From a management perspective, SaaS requires minimal effort, PaaS is balanced, and IaaS demands the highest management responsibility from the user. Cost efficiency depends on your usage and skill level. Choosing the right service model depends on user expertise, project requirements, budget, and desired control level. There is no universal best option. The choice aligns with your specific needs. In summary, SaaS focuses on usage, PaaS on development, and IaaS on infrastructure control. Control and responsibility increase as you move from SaaS to IaaS. Thank you for watching this video on the cloud computing model. Cloud enables progress. Let us protect what it carries.